All right, so today we're going to be talking about an idea related to power, work, engines, and that's efficiency. So really, efficiency is kind of like the grade that the engine actually gets. So if I'm looking at efficiency, if I'm just going to leave it kind of abbreviated EFF, we could kind of look at it as it is the amount of usable power divided by the amount of power produced, which isn't very useful, but really kind of think of it is our engine's producing a certain amount of power, but only some of it is usable. Other ways that you might see this is, if efficiency, if we're looking at it as a percent, we just take that times 100%, all right? So just the amount of usable power we're getting divided by the amount produced. Because no engine is 100% efficient, and that's going to go into like the second law of thermodynamics. Some of the work we do, some of our transfer of energy is always going to result in some loss of unusable heat. That's always going to decrease our efficiency. So we're going to look at this again later on. Like I said, efficiency is a percentage. For the most part, that's how it's kind of given. But we would know that, if they give us a decimal, that they're actually saving us a step. So let's just jump into practice problem number 1 down there. How much work is done by an 80% efficient 12 kilowatt engine in 5 seconds? All right, so they give us that the efficiency is 80%. Or 0.8 if I'm making that decimal. So really what I want to know is how much usable power am I getting out of that? And that's pretty easy. If I'm looking up here, that's just going to be the efficiency percent times the power produced and stuff. And so right there at the bottom there, it says that my engine produces 12 kilowatts or 12,000 watts of power. So we're going to take 12,000 watts times 80%. So the power produced times the efficiency, so 12,000 watts times 0.8 if I'm saving that step there. Can't do that one in my head. I should probably re-practice my math. All right, so 12,000 times 0.8. All right, so I have 9,600 watts of usable power. 9,600 watts of usable power. So this is how much I can actually make use of, right? So they want to know how much work is done. So to do this, we're just going to go through the power equation, the first power equation, I should say, which is just work divided by time. So in this case, I'm looking for work. So to get W by itself, we're just going to take power times time. So work is equal to power times time, which is 9,600 watts times 5 seconds. Bring this over. Times 5. 48,000 joules of work is how much work this thing could do. So 48,000 joules. Or if I want to use a nice low number, 48 kilojoules. So that's how much work we could do in number 1. Question number 2 then is going to build off of that. I'm going to scroll down. Just to kind of show you where our efficiency stuff is kind of useful. How high straight up could the above engine pull a 12 kilogram object with that amount of work? And keep in mind for this, I always consider that the amount of force that you're pulling up with, it's at least equal to the force of gravity. So here, let's find the force of gravity, mass of 12 kilograms, times acceleration due to gravity, 9.81 meters per second squared. Bring this over. 12 times 9.81. So I should have worded it as what's the minimum height straight up it could pull it. All right, so 107, let's call that 118 newtons. All right, so that's how much force I need to pull straight up. So I found work was equal to 48,000 joules Okay, now I have a force, and they want to know how high. So really, they want to know the distance. How high straight up could we pull this thing? So, so now I'm going to look at the work equation, which is work is equal to force times distance. Trying to get distance by itself, divide force over. Distance is equal to work divided by force. So in this case, it'll be 48,000 joules divided by the force we found out was 118 newtons. The minimum amount of force we would need is 118 newtons. So assuming we're going to do that, 48,000 divided by 118, roughly 407 meters. Keep in mind I rounded up twice there. So we could, in theory, if this engine applies, the minimum amount of force needed, it's going to move it roughly 407 meters if we're producing this much work. So that's pretty high. That's about a football field, a little bit longer than a football field. Well, probably a lot of bit longer. Don't know even why I said that. All right. So anyway, efficiency, the big takeaway here is this right here. Is we use efficiency to figure out how much usable power are we getting compared to how much power is produced by the engine. It's not all of it's being made usable. It's as easy as that. Good luck with the practice problems.